Hello everyone, welcome to this video on Mergesort. First, we will introduce what is Mergesort and with an example show the working of Mergesort. Mergesort is a sorting technique that was introduced by John von Neumann in the year 1945. It's a comparison-based sort, and it's called as merge sort because we combine multiple elements and form a single entity. It is a stable sorting technique. What do we mean by stable sort? Let's say we have a list of elements. 5 is duplicated twice. So I have the first occurrence of 5 and the second occurrence of 5. If after sorting, the first occurrence of 5 comes first and the second occurrence of 5 comes second, then it is called as a stable sort. The steps involved in merge sort are as follows. Input the data. Either you can input it as a list of elements or array of elements. Then we will divide the array into two halves at the middle, and we will sort each subarray separately. And finally, we will merge the sorted subarrays. Before we look at merge sort specifically, let's see how divide and conquer generally works, which is the basis behind merge sort. I take a problem. Let's say it is a problem to sort 4 numbers. So I have 4 numbers in unsorted order. I divide it into a subproblem. In other words, I have an unsorted list of 2 numbers. Again, I divide it into a subproblem. In other words, I have a list of 1 number which is to be sorted. And then I perform the computation, which means I sort the one element. And what is the sorting of one element? The element itself. So the final answer is a sorted list of one element. Now, after I finish the left side of the subproblem, I go to the right side of the subproblem. Please note, the size of my subproblem is 2. Left side, I took 1 number. So in the right side of the subproblem, I take the other number. Again, I compute it, which is nothing but sorting a list for 1 number. So I have 2 subproblems, one which has 1 element in sorted and the other also has 1 element sorted. With these 2, I will find the solution of the next bigger subproblem, which is 2 elements. And this is similar to having a sorted list of 2 elements. I have completed sorting 2 elements. Now I go to the right side of the problem. This is again the remaining 2 elements out of the 4 elements. I already have the sorted list of 2 elements here. Then these 2 elements are divided into 1 and 1. And then I combine them after sorting into array of size 2. Now I have an array in the right side which is sorted with 2 elements, another array on the left side sorted and with 2 elements. Now I can merge them in such a way that the sorted elements on the left and the sorted elements on the right are merged to get a sorted list of 4 elements. Please note the order in which we divided the subproblems and computed the subproblems. Now, the first phase is called the split or the divide phase. This is where we perform all the recursion till we split it into a single element, which is called as the base case. And the second part is what we call as merging. That is where we compute the problem for smaller subproblems and then combine the result to get a bigger problem. So the first step in merge sort is to divide the problem into 2 sublists where the division has to happen at the middle. Now let's see what happens when we have even number of elements. So I have 8 elements, 4, 1, 2, 5, 6, 3, 8, 7. I need to divide it at the middle. Now the formula which I will be depending on the index of the first element, which I call as low, and the index of the last element in my list, which I call as high. Here low is equal to 1 and high is equal to 8. The formula for finding the middle value is mid is equal to the floor value of low plus high by 2. That is the floor of 1 plus 8 by 2. That is the floor of 9 by 2, which is nothing but the floor of 4.5, which is 4. The mid value is 4. Now that my mid value is 4, I have to divide it into two sublists in such a way that the left sublist is from low to mid and the right sublist is from mid plus 1 to high. In other words, the first list is from index 1 to 4 and the second list is from index 5 to 8. You might be wondering why I did not take the mid value as n by 2. I could have just taken 8 by 2 and got the value as 4. But let's take another example. That is, I have the values 6387, but the indices are from 5 to 8. That is, the value of the first element is at index 5 and the value of the last element is at index 8. Now, if I apply the formula n by 2, I would get the mid value as 4, which would not be right, but rather I want the mid value to be 6. So let's apply the formula. Now low is 5, high is 8. I know that mid is equal to floor of low plus high by 2, which is nothing but floor of 13 by 2, which is nothing but floor of 6.5, which is 6. Now the sublists are from low to mid, which is from 5 to 6. I have the first sublist, and the second sublist is from mid plus 1 to high. Mid is 6, so mid plus 1 is 7 and high is 8. The sublists are 5 to 6 forms one sublist in the left side and 7 and 8 form another sublist in the right side. We have seen how to divide the elements when there are an even number of elements. Now let's see how our formula behaves when we try to divide at the middle with odd number of elements. So I have 9 elements now, and I use the same formula with low and high values being 1 and 9 respectively. Now the mid value will be nothing but floor of 1 plus 9 by 2, which is floor of 10 by 2, or the floor of 5, which is 5. The mid value is 5. Now the sublists that are formed are from low to mid, which is from 1 to 5 is the left sublist, and from 6 to 9, that is from mid plus 1 to high, I have the second sublist. So far, we have not yet ventured into merge sort. We have just seen that the list has to be divided into two and how to divide it into two and the formula behind it. In the second part, we are going to see after splitting what happens and how the actual merge process takes place. Step 1, we split at the middle. Now, the left sublist is considered. Again, I will split it. Please note, I'm not doing any computation. I'm just recursively splitting my list into two. And I have to keep repeating this process till there's only one element. If you remember right, the base case, we stopped when there is one element. So again, I will split it and I will look at the left sublist. I have 4 and 1. Again, I split it till I get a single element, which is 4. When there is a single element, I need to compute the subproblem. What is my main problem? Sort the numbers which are given. What is the subproblem? Sort the number 4. How do you sort the number 4? There is only a single element. There is no work to be done. I just need to take 4 as it is. Compute subproblem, we do nothing. So I have reached till the base case of the left side and I have computed the value for the subproblem. Now that the entire left side is completed, in the smallest subproblem, I have to take the right side. I have completed the left side. I take the right sublist of the parent, which is the innermost parent. The innermost parent has two elements, 4 and 1. The left sublist is over, and so I take the right sublist. Again, I compute the sorting of the single list, and there's no work to be done. One is sorted by itself. I have two values. So that is one on the left and one on the right. Let me conquer it. So to conquer it, I take 4, I take 1, and now the two sublists of size 1 are available. I will first create a temporary array, which is initially an empty array. Now, in the temporary array, in the first position, I need to fill it. I have two pointers. One to the first value in the left sublist, which is 4, and to the first value in the second sublist, which is 1. I compare 4 and 1. I see which is the smaller value. The smaller value is 1. I write it in my temporary array, and then I move the pointer. When I move the pointer, which is at 1, I have come to the end of the sublist, so that sublist is over. Then I move to the other sublist. There is still a pointer to 4. I will copy it into the temporary array. At the end of this, I have to first rewrite the first two values which I changed into the original array. So if you see, it was originally 41256387, but after I sorted the first two elements, it is 1, 4, and the rest of it remains as it is in the original array. Now let's do the same thing in the right hand side. So I've completed one side. Now my list is 14256387. Let me say it again. 4, 1 has now become 1, 4. Now I have to go to the right hand side. When I move to the right hand side of the problem 1425, that is, I have completed the left sublist of size 2. Now I'm going to the right sublist of size 2. I create a problem of size 2, which is 2, 5. Then I create a problem of size 1, which is 2 separately and 5 separately. In my temporary array, the third and the fourth indices are now to be written correctly in the sorted manner. So I have a pointer to 2. I have a pointer to 5. I check 2 and 5. As I said, it's a comparison-based sort. I compare 2 and compare 5. In other words, I compare the first element of the first list and the first element of the second sublist. Comparing 2 and 5, I know 2 is smaller, so I write 2 into the temporary array. And then move the pointer. One sublist is over, 5 is still remaining. I write it into the temporary array. At the end of it, again, I have to rewrite whatever was in the temporary array into the original array. When I write it, it is still remaining as 14256387. At the end of this process, the first two elements will be sorted. The third and the fourth elements will also be sorted. I have not yet touched the elements on the right hand side. I have two elements sorted in 1425 and the right two elements also sorted. It is now time for me to merge the two sublists which are of size 2. First, I merge sublist of size 1 and now I merge sublist of size 2. To merge sublist of size 2, we have two sublists of size 4 which are already sorted. Now we have to again combine them and make them into a list of size 8. So we have 3, 6 and 7, 8. I compare 3 and 7 and I write 3. I compare 6 and 7. I write it as 6. There is no element to compare in the first sublist, so I write 7 and I write 8. Now at this juncture, the left sublist is already sorted. Let me take the right hand side with the 4 elements, 6, 3, 8, 7. Split it at the middle. Take the left sublist. Split it at the middle. Take the left. I am stuck with a single element. I can do no more splitting. So I go to the right sublist. Then I compare 3 and 6 and write 3. And then I write 6. The left sublist of 6, 3, 8, 7 has been computed and sorted for 2 elements. Now I go to the right sublist, 8 and 7. I split it, divide it into 8 and 7 separately. And now I have lists of size 1. Compare 7 and 8, write 7. The only element left is 8, so I write 8. In the original array, in the right-hand side, when I rewrite it, it is now 3, 6, 7, 8. After computing subproblems of size 1. The left sublist of 6387 is already sorted with the values 3, 6 and 7, 8 respectively. I still have it as 2 sublists. Now I have to merge them into a single sublist. In the previous step, we only took elements of size 1. Now we have elements of size 2. I compare 3 and 7. 3 is written in the temporary array because that's a smaller value. Move pointer to 6. Compare 6 and 7. Write 6 in the temporary array. Now there are no more elements in the first subarray. There's no element for comparison, so we just write it as 7 and 8. So I have now combined 2 sublists of size 2. And then rewrite it in the original array. There is no difference between the values when I combine single elements and when I combined lists with 2 elements. But at this juncture, all the elements on the left side will be sorted. 1, 2, 4, 5. All the elements on the right side will also be sorted. 3, 6, 7, 8. And the size of the sublist is 4. I have 2 sublists of size 4. Now I conquer them. I have a pointer to 1. I have a pointer to 3. The smaller value is 1. Move the pointer from 1 to 2. I compare 2 and 3. The smaller value is 2. I write 2 in the temporary array. Move the pointer to 4. I compare 3 and 4. 3 is the smaller value. I write it in the temporary array and move the pointer to 6. 4 and 6 are compared. 4 is the smaller value. And move the pointer to 5. 5 and 6 are compared. 5 is written into the temporary array. And we have now seen the entire left sublist. Now there are still 3 elements pending in the right sublist and already they are in the sorted order. So I just need to write them down as 6, 7, and 8. This is possible because both the lists are already sorted. Now the original array becomes 1, 2, 3, 4, 5, 6, 7, 8. When we rewrite the temporary array into the original array. To conclude, we have seen how mergesort is performed. We have also seen how the recursion actually takes place. To summarize, we first keep dividing and splitting it towards the left, and only when we reach the base case do we start looking at the right sublist from the innermost parent. This is the basic concept for any recursion. And in the next video, we will write programs and we will see algorithms to implement a mergesort. Thank you.